So, relative velocity as the name suggests, relative velocity is velocity of some object with respect to another. It is given by time rate of change of position of one object with respect to another. Relative velocity of a body, let us say b, with respect to some other body a, is given by velocity of b with respect to some other body a is given by velocity of b, which is read as v sub b, minus velocity of a. This is essentially velocity of b as recorded by an observer sitting on a. So, mathematically it is defined as velocity of b with respect to a is equal to velocity of b minus velocity of a. So, we will provide a simple proof for this. We will write x y axis, and there are two objects here. This is particle A, this is particle, or let us say particle A, and this is particle B, and the position vector is given by part r sub A, and this is r sub B. If we were to write the position of object B with respect to A, we would write this as position of object B with respect to A. Obviously, there will be a vector, and it is represented by an arrow over here. This is a vectorial addition going by the triangle AOB here. We can write this as r sub BA, which is nothing but this one, plus r sub A is equal to r sub B. If we want to write RBA, that is equal to RB minus RA. Now, differentiating the above expression, the above expression that means to say we are differentiating with respect to time. So, time derivative of position vector of B with respect to A, we will put a bracket here, is equal to time derivative of position vector R sub B minus time derivative of position vector R sub A. So, this is nothing but this is nothing but velocity of B with respect to A is equal to velocity of B minus velocity of A. Remember here, velocity of A could be in any direction, it does not matter. So, as long as we are taking position vector, it should not matter for us. So, this is velocity of A and velocity of B. Therefore, velocity of B with respect to A is given by velocity of B minus velocity of A. Similarly, we can write velocity of A with respect to B is equal to velocity of A minus velocity of B. Velocity of A with respect to B is equal to velocity of A minus velocity of B, and hence the proof. This is how it can be assumed to be true. So, now we will also explain graphical method to find relative velocity. When two bodies move at an angle theta with each other, then their relative velocity is given by let the two bodies move, this is VA, the other one is VB. This is the angle between them is theta here. This is alpha. So, we are now finding the magnitude of B with respect to A, or velocity of B with respect to A is equal to velocity of B minus velocity of A and therefore, magnitude of velocity of B sub A is equal to magnitude of B sub A, and this is equal to square root of V sub A whole square V sub B whole square plus 2 VA VB cos 180 minus theta, cos 180 minus theta. So, this is equal to V sub A whole square V sub B whole square minus 2 V sub A V sub B cos theta. Minus is because 180 minus cos 180 minus theta is minus. So, we are in fact taking the angle here, this is in fact V A So, we are taking the angle between this and this, and this, that is 180 minus theta. So, similarly the direction is given by tan alpha. So, going by the formula V sub B sin 180 minus theta whole divided by V sub A plus V sub B cos 180 minus theta. This is bracket here, and this is nothing but tan alpha is equal to VB, that is sin theta. Sin is positive in the second quadrant, therefore it is sin theta whole divided by VA minus VB cos theta, because here it is cos 180 minus theta. Cos theta is negative in the second quadrant. We consider a problem here. Car A is traveling north at 20 meters per second, while car B is traveling east at 25 meters per second. So, what is the velocity of B relative to A? What is the velocity of car B relative to car A? So, we will write this. We will take xy axis here. Sorry. This, we will consider another coordinate axis here. X. So, here velocity of B is towards east. This is velocity of B towards east, and it is given by it is given as 25 meters per second. That is, it is traveling along x axis. It's traveling along x axis. Therefore, VB is equal to 25. I is unit vector here. So, 25I plus, there is no y component here, therefore, it is 0j. And similarly, car A is traveling north at 20 meters per second. This is car A. So, therefore, VA is, there is no x component here, therefore, we write 0I plus 20j. So, now we have to find relative velocity of B with respect to A. As we know, relative velocity of B with respect to A is defined as velocity of B minus velocity of A. This can be written as, since plus negative of velocity of A. So, that means to say, we will write over here, velocity of B is this, and negative of velocity of A is in this direction. It is same as velocity of A, but as far as the magnitude is concerned, it is the same, only the change is only in the direction. So, this we need to join we will name them a little later. So, this is velocity of B, we write this as velocity sub B, and this is minus of velocity of A. Magnitude is one and the same, only difference being the direction. Therefore, V B plus minus V A is given by this vector, this plus this. Triangle law of vector addition gives this as this. Therefore, velocity of B with respect to A is given by this vector. So, how do we calculate this? It is simple. Velocity of B with respect to A is equal to velocity of B is, as we know, is 25 I plus velocity of A is plus 20 j, but here it is negative of that, therefore, it is 20 minus 20 j, which is equal to 25 I minus 20 j. So, what is the magnitude? So, magnitude of vector B A, velocity of B with respect to A is equal to square root of 25 square plus 20 square. We need not have to take minus here because there is a square. So, this will be 32 plus approximately it will be 32 point minus 02 meters per second, and we need to find the angle here, the angle it is making with x and y axis. So, again by the definition of a vector, we can write this as tan theta is equal to 20 divided by 25 y by x in fact. So, this is nothing but theta is tan inverse of 20 by 25. So, we shall consider slightly complicated stuffs in the next class. Before that, we will give you some introduction to how to handle such problems. So, we will stop here. Thank you.